electric field due to a thin spherical shell of charge. Look at this diagram. This is a spherical shell of charge which is having radius capital R, containing charge Q on the surface, having charge density sigma, that is charge per unit area sigma. So what is the total charge on the spherical shell? We can write Q equal to area of the spherical shell is 4 pi r square. Charge per unit area is sigma. So Q equal to 4 pi r square sigma. That is the total charge on the spherical shell. Now we calculate what is the electric field capital E on the Gaussian surface S dashed, where the Gaussian surface is of radius small r and small r is greater than capital R. Let us consider this as case 1. Here the Gaussian surface encloses the charge Q. Charge Q is well inside the Gaussian surface. According to Gauss theorem, integration over the surface E dot ds equal to Q by epsilon naught. And we integrate over ds, so that on the Gaussian surface electric field is remaining same, since it is a symmetric spherical surface for the spherical shell we consider. Hence we write this equation as E integration over S ds, I just write the magnitude, equal to Q by epsilon naught. Already we know what is Q. Substituting E we need to calculate. E on the Gaussian surface we need to calculate. E into over the Gaussian surface we calculate, that is over S dash, that is the total surface area of the Gaussian surface, which is equal to 4 pi small r square equal to, substitute for Q, 4 pi capital R square into sigma divided by epsilon naught. Now these quantities can be removed. 4 pi get cancelled out and we get E equal to sigma by epsilon naught into capital R square divided by small r square, which is the magnitude of electric field due to a spherical shell of charge outside the shell. Any point if we take outside, electric field depends on radius of the spherical shell and distance of the point from the center of the spherical shell. If we imagine the system is placed in vacuum medium or free space, permittivity is absolute permittivity epsilon naught and sigma is the charge density. Vectorially we represent E equal to sigma by epsilon naught capital R square by small r square into unit vector n, where unit vector n represents the direction of electric field. Now let us consider second situation, that is case 2. In case 2, just imagine the Gaussian surface is on the spherical shell itself, which means S dash and S are coinciding, that time we can write small r is equal to capital R. This is the second situation. That is, when the Gaussian surface is on the surface of the spherical shell, this equation will get changed to sigma by epsilon naught capital R square, here small r, capital R both are same, into capital R square, which is equal to, we can cancel out, which is equal to sigma by epsilon naught. Or we can say, on the surface of the spherical shell of charge, electric field vector equal to sigma by epsilon naught into unit vector n. This is the electric field on the surface. Magnitude wise, E equal to sigma by epsilon naught, which is the magnitude of electric field on the surface of the spherical shell of charge. Now let us consider a third case, case 3, which is, we imagine the Gaussian surface to be inside the spherical shell of charge. Gaussian surface is well inside the spherical shell of charge. I just extend it. Just imagine this is our spherical shell of charge having charge q, and Gaussian surfaces inside the spherical shell of charge, or both the surfaces are coaxial. Both are having same center O. So this is our spherical shell of charge having charge q, spherical shell is of radius capital R, and this is our Gaussian surface, which is of radius small r. Gaussian surface is of radius small r. So our Gaussian surface S dash, and this is our Gaussian surface S dash small r, and this is our spherical shell of charge S. Spherical shell of charge S. Gaussian surface is also a sphere, that is S dash. Now let us apply Gauss theorem. According to Gauss theorem, we know integration over the Gaussian surface we calculate. S dash E dot ds equal to q by epsilon naught. The charge q is outside the Gaussian surface. Here also uniform charge density sigma. And the entire system is placed in vacuum medium. Hence absolute permittivity epsilon naught. So here we write E is the one we are going to calculate on the Gaussian surface. E into surface area of the Gaussian surface is 4 pi into small r square. No charge is present inside the Gaussian surface, hence q equal to 0. or we write E equal to 0. The situation is when small r is less than capital R, or when the spherical shell of charge is of radius capital R, when capital R is greater than small r, electric field due to the spherical shell of charge inside it will be 0. Thank you.